Hey everybody, welcome back to another AWS OnAir sponsored segment brought to you by NVIDIA. I am Todd Fortier, a senior solutions architect here at AWS, and today I am joined by Eliuth from NVIDIA and Vara from AWS. Eliuth, why don't you introduce yourself and we'll kick this thing off.
Thank you, Todd. Yes, my name is Eliuth Triana. I lead all the global developer communities on AWS, so we can help you accelerate all of the GenAI optimizations for GPUs and for AWS when you're running your GenAI. So today we are going to talk about NIMs. NIMs has been very popular. Jensen, the NVIDIA founder, has been talking about NIMs as the tool to optimize GenAI. So let's learn about what the NIMs are, how you can deploy NIMs on EKS. So that's going to be today's session.
Yeah, thanks, Eliuth. Welcome back to the show. I think we've talked before. It's good to see you again. And Vara, why don't you start by introducing yourself as well?
Yeah, sure. Thanks, Todd. Thanks, Eliuth. Hi, everyone. My name is Vara Bunto. I'm a principal open source solutions architect working with AWS strategic accounts mainly. And today I'm going to talk about the data on EKS as one of the open source projects and how we can use data on EKS to actually deploy NVIDIA NIM inference containers on EKS. So we will delve more into the demo and other things as a part of this session. Yeah.
Cool. Thanks. Yeah. Welcome to the show. So today we've got NIMs. That's a product we've heard before on this show. And we've also got EKS, and we're going to talk about how they can be joined together to supercharge some AI ML inference workloads. So, Eliuth, let's start with you again. Remind us what NIMs is and what do customers get from using NIMs?
Absolutely, Todd. So our team has been working really hard with so many customers and partners in optimization. So optimization on top of the GPU is all when you are running GenAI workloads. So either doing training or inference, you have to make sure that you optimize using the right software on top of your GPU instances on AWS. So today we will run our NIMs, which is, as Vara was saying, NVIDIA NIM solution. It's a container that you can get with a runtime to run your inference performance workloads. So whenever you are running your inference for your models, you can run it on an NVIDIA NIM that will be state-of-the-art performance. So it has all the optimizations within the container. So you can run it on the specific GPU, you can run it with the specific techniques like a sparsity or like any other techniques that can help you to get the best performance. Whatever you do is like this container will help you to get best latency, accuracy, and throughput for your performance models. So let's go to the slide. In the slide, we will see how you can get the difference between doing all the optimizations yourself versus doing all the optimizations using the NIM. So first is you can learn that it will be easier to deploy, so you can run it anywhere. You can be secure, so it will contain like the secure environment versus the open source environment. When you have to secure it yourself, the NIM will be a secure environment already. It is like an optimized infrastructure, optimized technology. So for the right GPU, it will have the best performance. It will have custom code, so for any other model that you will be running. And it will be like our NIM factory. So we will have ongoing maintenance for the NIMs. So it will help you to reduce the time for optimization on your inference workloads. Let's back to the stage. So we can just select a few features that we can have on this engagement. One is you can deploy anywhere your NIM container, so you can run it on EKS, or you can run it on SageMaker, or you can run it on EC2 GPU instances. It will be a simplified deployment, so it will be easy and really simple for you to deploy those NIMs. There will be like a day zero support. You will get all the support from either NVIDIA and AWS on your runtime environments. It will improve the TCO, so you will make sure that you have the best performance for the GPU you are running. Accuracy, latency, and throughput are the features that you will highlight using the NIMs, and you will get all the performance running an enterprise software. So we have this licensing mode, which is NVIDIA AI Enterprise licensing mode that will help you and will give you all the support and all the backend from NVIDIA to help you run your inference. So with that, what we're going to do is deploy on EKS, so you can see some examples. You can see how easy it is to deploy, and we will be here to answer your questions.
Okay, very cool. So Vara, I'm assuming that's what you're here to do. You're going to show us exactly how we can run the NIMS product inside of EKS, which is an AWS service. Let's first start with EKS.
Yeah.
Remind our audience what EKS is and why they might want to run NIMS on top of EKS.
Yeah, sure. Thanks. So just to start with, Amazon EKS is a fully managed Kubernetes service. So a lot of you know about Kubernetes, and AWS's managed service is called Amazon EKS. And so when I say fully managed service, it's mainly the control plane. It's a fully managed service, and the data plane itself, the users will leverage various EC2 instances or a Fargate, various type of compute, and deploy their containers on EKS. And that's pretty much what Amazon EKS is. And then moving on to deploying containers, like Elliot said, and NIM is a container. So today, if you want to deploy any of the inference workloads like Llama 2 or Llama 3, or even Mistral, so those kind of models that you can deploy in Kubernetes, which is, in our case, is Amazon EKS, as a container, and then you scale horizontally and leverage the container orchestration capabilities that Kubernetes provides. And that's what we're going to look at today, and how you can easily deploy and manage and scale that to a large scale workload.
Yeah, very cool. So, okay, I got it. Containerization, NIMS comes prepackaged as a container, and we can scale that on EKS, a managed service on AWS. Okay, so you've got a demo for me. Should we see this thing in action?
Yeah, sure. So
Cool.
let me share my
Let's bring
screen.
it up.
I might be moving my head both the sides because I have two screens. But as you can see here, so let me start with the data on EKS. And you heard about Amazon EKS, but data on EKS is an open source initiative we started a couple of years ago. This is mainly to help our customers to scale data and ML workloads on Kubernetes on EKS. So this consists of a bunch of blueprints to deploy various data solutions, and also ML solutions. Comes with best practices, benchmarks, and some of the resources. So this is a useful tool if you want to get started with doing any AML workloads or generative AI workloads. You can start with the data on EKS. So today, I'm going to show you the demo how you can actually deploy NVIDIA NIM, using data on EKS blueprints, and show a couple of examples. And we can send some test prompts to verify the NVIDIA NIM blueprint. And then we can look at some of the Grafana dashboards as well to see the visualization of the NVIDIA NIM deployment. So without any further ado, let's get started. So as you see here on the screen, if you want to get started with the generative AI, I would click on the generative AI button there, explore that. And because we're looking at NVIDIA NIM, we have a number of patterns here. We have training and inference. Because it's an inference pattern, I would go to inference. NVIDIA NIM runs on GPUs. So I'm clicking on GPUs. And this is the blueprint I'm talking about, NVIDIA NIM LLM on Amazon EKS. So if you are thinking about deploying NVIDIA NIM on EKS, I would say this is the best place to start with. You have all the data and clear instructions on how to deploy it. But I won't be doing that as a part of this demo. Probably deploying the solution probably take around 17 minutes. When I say 17 minutes, that includes creating an EKS cluster, deploying the nodes, and deploying NVIDIA NIM, and so on. So for that sake, so we're going to skip some of those steps and I'll jump on to show you the cluster and other things. Yep. So, and this is I would like to show you this architecture. This gives you a little bit of overview before I jump into the demo. As you can see here, this is the blueprint that we are deploying as a part of this, the deployment, NVIDIA NIM deployment. So NVIDIA NIM provides multiple models that can be deployed in EKS. The way we do it is, in this case, we are using a Helm chart. And within the Helm chart, you can specify which model that you want to deploy. But for today, I'm going to show you Llama 3 8 billion parameters model that we're going to deploy it, and we can see some scaling using Carpenter auto scaling. So when you deploy, you can have one replica, one container running on EKS, but then by using horizontal pod auto scaling with custom metrics using Prometheus and Prometheus adapter, and you can choose, in this case, I'm using number of requests running, and then you will see the number of pods scaling horizontally and creating new nodes and new pods to actually take over the load and horizontally scale the whole workload. And this is like an EKS cluster. You see the two worker nodes, G5 2x. In this case, I'm using the smallest instance that we're going to see in a minute. And these pods are backed by a NIM K8 service, exposed by the NIM K8 service. And even that service is backed by the load balancer. That means the users who are consuming this will be using the load balancer that can be NLB or ALB, but I'm using NLB with Nginx here. That's another pattern. And then you can send prompts to these nodes and get a response back from the server. And the scaling happens to the Prometheus. And the most important thing is these models, when we pull from NVIDIA NIM, and we are storing these models as a cache in EFS here. You see that we are leveraging Elastic File System as a shared file system that can be used by across all the pods. Even if the horizontal scaling kicks in, they're all connected to the EFS and pull the model and then leverage the model, which is nice. We can take a look at that in a minute. So that's kind of an end-to-end architecture. We're going to see all of that in a minute. So to start with, simple instructions, and you clone the repo. You need NVIDIA API key. So before you start working on this, deploying this, and there is a developer key, probably Elliot can answer that from NVIDIA, and you can go and get the developer key, use that key to deploy it, because that's what, but if you want to run it in production, you have some licensing things that you need to work with NVIDIA there. But then from the EKS perspective, if you have AWS account, and then you can go and deploy it. You don't need any specific license, but just make use of, think of like usage of what you're deploying for it. You pay for those instances.
One thing, but add to that is you can get that key from nvidia.ai.com.
Cool. So we're gonna take a look at that, and we have some instructions around how you can get the key here. We kind of explained it in more detail, and then shows that key, how to extract the key, how that key can be used within the deployment. We export it, and then finally, that's one command, install.sh, that goes and deploys your cluster, deploys your model, and make that model ready for you. So I'm going to show you the code in a minute to see exactly where the NVIDIA NIM is getting deployed. So switching back to my VS Code here, and that's the deployment.
So Var, this is code that you got from the GitLab, the GitHub repository that was available. So you ran through the prerequisites, make sure you had everything set up in your AWS account. You have an API key, pulled the code down. Now we're looking at the code. Okay, yeah, let's go through the code really quickly, because I want to see this thing in action and make sure we have enough time to see some inference.
Yeah, sure. So, right. And this is the blueprint. And the key thing I wanted to mention here is I won't go through that. All this code is written in Terraform in this case. We have other, it's mainly focused on the Terraform, but if you are thinking of using some other infrastructure as a code, we can easily convert into that. But then the key thing here is this deploys an EKS cluster, and that goes and deploys an EKS cluster. We won't go through that code anymore. But then we are using Carpenter to scale the nodes. So that's one of the add-on that goes in. Carpenter is an autoscaler from AWS, and that runs on Kubernetes and EKS in this case. And that will help you to actually spin up these instances at runtime based on the workload. And then moving on to the key variable. So to deploy NIM, to make it easier, what we did, we automated the solution using, the NVIDIA's NIM Helm chart. And all that you see here is I have two options here. I mentioned two default values. One is deploying Llama 3.1 8B instruct, and deploying another model, Llama 3 8B instruct. So you can enable and disable the model, and you can also add multiple models within that variables. And then you go and run Terraform apply that goes and deploys all those NIM containers. That's the simplicity. But then now switch on to the cluster. Yeah, there's a question?
Yeah, no, I just wanted to clarify. So this code is already done for you. It quickly, you can add or customize that code to your liking, add in additional plugins. But you've already deployed that code into an EKS cluster, and now what you're showing is actually interacting with that. And we've got just a few minutes left, so I want to make sure that we get a chance to infer some things against NIMs.
So let's do the, because the model is deployed, I'm going to switch back to the Lens. It's an open source tool, not open source license tool. We can visualize that. And as you can see here, this is an NVIDIA NIM container that I deployed as a part of this. This one pod running at the moment. And we can access the NIM using, to access and send a prompt. I actually deployed an open source OpenAI web UI. And that's another part, which is talking to the NIM and get the response back. I want to give you something similar to what ChatGPT is like. You can send a prompt and get a response back. Let's go to that deployment. Let me show you real quick, switching on to the another browser here. Okay. So as you can see here, I actually connected to this. This is open web UI. I connected to the model that I deployed, and I'll show you the code in a minute. That one, and this actually talks to the EKS model deployed on the container, and you can ask any question here. So this is going to get send a request to the NIM container, get a response back using Llama 3 8B instruct, and say, do you have anything in mind, Todd? Second type.
Not that I can think of. How about like, hey, there you go. I see. What is generative?
I'm gonna put what is NVIDIA's NIM and see what comes out. That's right. Right, there you go. Wow. You're getting a response back as something, it's pretty awesome. It's an OpenAI server. Yeah, go on top.
Yeah, super fast too. So I just want to real quick recap. We're running out of time. So we have the NVIDIA NIMs product that you can use. It's already been containerized for you. You can find that code on the GitHub data on EKS, and then we've deployed that container into an EKS cluster, which is managed by AWS. And then from there, we can use tools like Carpenter to scale more clusters or scale more pods and nodes to get really the most performance out of NVIDIA NIMs. And a lot of that work is already done for you. So if you're interested in learning more about NIMs, there's a blog that we'll have a link to, or you can go to data on EKS and follow the tutorial and get started really quickly. Hey guys, thanks for coming on the show. That was a really cool demo, and I hope to see you again next time.
Yeah,
thanks,
Elliot.
Back to you guys in the studio.